Hello, well, my name is Nicholas Leifger, and welcome to Week 6 of GMGT 590, Operations Management. What we're going to talk about this week is a smattering of several topics, various things that you may encounter when you're out in the real world, when you're out working in a business. And what I want you to get is an understanding of what's going on, and an understanding in some cases of why it's going on. Those topics include lean processes. We'll talk about what makes a process lean. We'll talk about risk pooling, and how combining the variations of several different sources of demand can lead to savings in the long run. And we're going to talk about the basics of MRP and ERP systems. In essence, one of the things that we're going to look at today, when it came to processes at the beginning of the course, you were taught how to look at the basics of a process, what it could do, and then in the second week, how you could possibly improve it. What we're going to look at today is some details with regard to that, how to look at a process in a little more detail. And to that end, we have things like value stream mapping and process improvement. So what we're going to do is we're going to shine a finer microscope on the process and ultimately how to improve the processes that we work with. In essence, what we worked with before was a process where everything was a given that it would have to be a part of the process. That isn't necessarily the case. There are a number of things within a process that, frankly, aren't needed. So the question is, how do we examine a process and see which parts of this process are redundant or really not needed? So we want to remove the waste from the process. And by doing this, by removing the waste from the process, and that includes reducing inventory in the process wherever possible, we come up with what is known as a lean process. And that is the goal in this case, a process in which most of the waste is removed so that we have a lean process. And that's the technical term, a lean process. So what's going on here is that we are trying to maximize the value of the process by getting rid of anything that doesn't have value in the process. Now, to that end, we need to define what value is. It's something that the customer wants. It's some utility, some benefit, or some reward that the customer is willing to pay for. So, in essence, if it adds something that the customer likes, it has value. Not everything in the process has value. So how do we eliminate what doesn't have value in the process? So if the goal is to preserve value, to not destroy value, well, how do we destroy value with waste? Well, there's a bunch of different ways we can do that. Overproduction. If we make too much, it becomes difficult to sell. Waiting. If the goal is to take money, transform it to stuff, and then transform it back into money. Transportation. If we don't need to send something halfway around the world, why send it halfway around the world? Inefficient processing. If it takes us 10 minutes to get something done that should take 5, well, that's a problem. Inventory. I've already talked about this in some detail. Unnecessary motion. If you have to go around all over the place to get something done, and you don't have to, well, that's an issue. That's a problem. That's time wasted. And then there's this idea of product defects. This idea that if you make something and it isn't worth selling, well, what's its value? Not all that much. So there's a lot of things that produce waste within a process. The goal here is to try to eliminate as many of those as we possibly can. Now, if the goal is to enhance the value that gets to the customer, we have a number of tools that are available. Some of these we've already talked about in one form or another, in particular in week 2. Some of them, well, we haven't talked about. For instance, simplification. The easier something is to do, chances are the better that somebody's going to do it. System integration. If we have steps in a process that are similar, it might be a good idea to combine them into one step to have all of this occur at one point with the same machinery, the same people. Standardization. Well, we see this fairly commonly when it comes to service operations. If people do the same things every time, that reduces variance. We've talked about variance before. Sequencing activities. We saw this before when we were trying to separate these tasks into workstations. Sometimes this helps. Parallel activities, and if you will, going back to week 2, this is like having multiple stations for a particular step in a process. If you will, replicating that station. Sometimes that helps. Variance control. By reducing the amount of variability in the process, in general, that makes the process better. We saw that with quality. Focusing on core competencies. If we make sure that we focus on what we do well, and only what we do well, and then outsource what we don't do well, chances are we'll be less distracted and focus on, well, what we do best. Automation. If we take these inefficient procedures and give them to a robot, for lack of a better way of putting it, all of a sudden the variance within that step in the process tends to be reduced, because with automation it'll be done pretty much the same way almost every time. Then, of course, extra resources, putting more people into the process. All of these things can enhance value when it comes to dealing with our process. So, as with any good problem solving, it's sometimes a good idea to organize things. And how we organize things here is we start with what's known as a process flow table. We make a list of every step in the process, in order, and what it does. And if something is done to the process, we need to list it on this table. So what do we put on this table? Well, if it travels any, we put the distance that it travels, the amount of time that a particular item takes at this step, what type of step it is, whether it's an operation, where we do things, whether it's a decision, we decide what to do with this particular product. If it's transportation, if it's inspected, if it's just a plain old delay, if it's a storage where it's put in inventory, we need to write this down. Number of people involved, and a couple of other things, most notably this thing called a value code. Now that value code, that'll become important for when it comes time for improving the process and specifically dealing with the value with this process. We also give a description of the activity where we basically say what's going on. All of this information needs to be put in a process flow table so that we have this list as to what's there, when, why, who, what, when, where, why, and how, if you will. As I was saying, each step in the process, each item listed in this table has a value code. And the value code can have one of 3 values, if you will. It can be value added, which means that whatever's done here makes us money. It's something that the customer wants. It's something that the customer likes. It can be non-value added but necessary. Sometimes these things happen. The action doesn't make us money, but it's not something that we can eliminate. Examples of this: regulatory requirements. So if the law says we have to do something, we have to do something, at least within that particular place. Also, if there's no substitute based on current technology, well, no, we can't get around that either. And then there is non-value added, where it's a waste. Here, This is stuff we want to eliminate. This is stuff that we want to get rid of because, frankly, it's something that we need to get rid of to maximize the value for a process. And that's the goal here, to maximize value for the process. Now, once we have these steps listed, it's time to draw out the value stream map. This will look like a lot like the process maps that we saw early on in the course, but in a lot more detail. This is what we want an idea of where we are now. Before we can figure out where we need to be, where we want to go with this process, we need to figure out where we are now in as much detail as possible. So, we want to get a picture of what's going on. And that means a level of honesty here. We can't overlook delays. It's not a case where we have just hand wave steps where it sits in inventory for a week. That won't work. In fact, that's the waste that we need to get rid of. Now, it's always a good idea to map a process in different ways because this will tend to give us different perspectives on our process. If necessary, and sometimes this is necessary, you may have to staple yourself to an order. What's meant here is that you take an order from beginning to end. You take a product from raw materials to the finished goods, and you walk through it every step of the way. There's a very good reason for this. There's things that aren't written down. There's things that aren't documented. By stapling yourself to an order, you tend to find them. One of the best examples of this, and this is a fairly old example, but it's still a good one. Back in the 1970s, computer programs weren't put on floppy disks. In fact, floppy disks were fairly new technology at the time, but most computer programs were actually printed out on punch cards. You would feed the punch cards into the computer and that would load the program into the computer. Well, an American software company wrote a program for a French firm, for a French company. And French company got the program, ran it through the computer, and it would error out each time. There would be some problem whenever it was loaded, each and every time. And the Americans couldn't figure out why, and the French couldn't either. So finally, an American got on a plane to Paris with these punch cards in hand, with the computer program in hand. They got off the airplane in Paris, went through customs. The French customs agent pulled out one of these cards, one of these punch cards, took a look at it, took it as a sample, and walked away. So, they finally figured out what was happening to these computer programs. These customs agents were taking a small part of the computer program. And, imagine if a hard disk with a sector that's corrupted. It's the exact same thing. All of a sudden, part of the file, part of the program is gone. But only by walking it through the process, by stapling themselves to the order, could they find this problem. So what goes on this value stream map? Like I said, a value stream map is a lot like a process map, only it has a lot more information. It has all the locations, all the process steps, has the flow time, throughput, has a flow time through each step, time and inventory, how long it stays in a particular part of inventory, the amount that's in inventory in this place, the amount that's actually worked on, things like cycle time, any delays. In essence, a huge amount of information, including things like information flows, transportation flows. These can be important. A good way of thinking about how important information flows can be. There was an apparel company that had their apparel made overseas. And of course, the time from when these designs occurred to when they actually would get to market, they wanted to make that as short as possible. And yet, they were sending these files through regular mail, which, as you can imagine, internationally, takes a while. Eventually, they figured out sometimes using FedEx is a good thing. So they began FedExing the designs to their manufacturers so that they could get these designs to the market much more quickly. So, within a value stream map, if it's an important part of the process, if it's an important part of the information, the transportation, anything with regard to how the process runs, it's a good idea to put it in this process flow map. With a value stream map, we use a lot of the same symbols that go into a process map, but there's a lot more detail. Rectangles are still operations, locations, things done. We have storage areas. We generally represent these with triangles as usual. We have decision points. There's areas where the process may branch into one area or another. We have a symbol for that. We have flows of material. Where the physical good in the process goes from beginning to end. But we also have flows of information. Things like orders, things like designs. And of course we have process delays. All of these symbols we will use in a process flow map. So, when it comes to lean manufacturing, there's a few rules we need to remember. First, what is value? What does the customer look for? What does the customer want? This is important. With any good problem solving, you want to start with what you want. And in this case, we need to start with what the customer wants. And it's important to keep that in mind. A good way of thinking about this. When a person buys a drill, they don't buy the drill because of the spinny part. They buy the drill because of the hole that it makes. So we need to remember what the value is for the customer and what is important to them. Once we know what we want, we need to figure out where we are now. We need to identify the value stream. We need to identify all of those actions from start to finish that give the value to the customer, that deliver the value to the customer, so that we know what's needed and we know what is waste. The goal here is to make the value flow without interruption to the customer. We want to get the value to the customer because if they have the value, they will give us the money. So, to that end, we want the customers to pull the value toward them. Let their requirements shape our process. Let their requirements decide what we need to do. When lean processing is done to its fullest, their demand is what will determine our production. And then finally, once we've found this, we try to perfect our process. This is not a case where our process is perfect and then we sit back and relax. We must continuously pursue perfection. We must continuously improve our process so that our job, getting value to the customer, is constantly made better. So, here is an example of a value stream map. And here what we're doing is we're making springs. Springs for automobiles. Well, if you look at this value stream map, there's a lot of problems here. You'll note that there's a huge amount of inventory in between each step. If you take the amount of work that's actually done on each item, it comes to just a couple minutes, right? But if you look at how long it takes from beginning to end for a particular item, it takes a couple of weeks. This is not a good process. So, if it's not a good process, what can we do to improve it? Well, let's see. We have these two welding steps here. So it gets welded, and that takes about 38 seconds. And then it goes back in inventory and waits for a couple of days. And then it gets welded again for a grand total of 46 seconds, or 45 seconds, sorry. Why not combine these two welding steps into one? That way you don't have this 1.8 days of inventory that's just sitting there. The same thing is true for the assembly steps. You have assembly taking 61 seconds, and then it sits in inventory for 2 days before it gets assembled again for 39 more seconds. Why? Why not combine these two steps into one so that you don't have these inventory areas at all? There's other areas where we can improve things. For instance, we have shipments of raw material coming in twice a week, Tuesday and Thursday. Why not have more regular shipments? Have shipments come in daily or twice daily. That way you don't have this large amount of inventory, 5 days worth of inventory, that's just sitting there. So, overall, what a value stream map does, you take this map and you see the process. You see the process in all its warts, all of the areas where product sits waiting, all of the areas where you have shipments coming in twice a week. You see all the areas where product is sitting around doing nothing. And you see how much of the process is actually contributing to the product that the customer gets. And in this case, there's a grand total of 166 seconds of work that goes toward the customer. The problem is it takes 23.5 days for the process to finish. So, there are other things that we can do. We can see about reducing the variation in the process. We can see about improving the lines of communication between each step, not only between us and our suppliers, but between us and our customers, so that we have a better idea of demand. So, overall, what the process map does, or what the value stream map does, is it gives us an idea of what's going on now, so we can make a picture of what's going to happen in the future. So, ultimately what we do is we find these sources of waste. We find places that the process can be improved. And based on the current map, we come up with a future state map. The idea here is to take what is now and make some idea of the future. And we've already come up with some ideas in this regard, such as combining the two welding steps and combining the two assembly steps and increasing the number of shipments of raw materials that come to us so that we have less raw material waiting. All of these are examples of things that can be done to improve a process. Other things that may be useful: decreasing variation, more shipments to the customer, more frequent shipments to the customer. That way, finished product isn't waiting around. All of these are things we can do to improve our process. All of these are things that we need to do to improve our process, and that is what a value stream map does. It allows us to see a picture of what's happening now, so we can make a picture of what our process should be.